So now we've got Dan Laird from Ericsson, who's going to present their solutions.
Right, yep, so myself, I'm Dan Laird. I'm the head of software control and processing at Ericsson Telly. It's about 50 people in my group and about 130 odd in engineering in total, covering hardware, firmware design and software. The obligatory, what do we do? So we're Ericsson, everyone immediately thinks mobile phone masts, or if you ask other people, they remember Sony Ericsson mobile phones. We actually do television. So we were Tamberg Television, for those that have been around long enough to remember that, and we're over at Junction 7 at Hedge End. And Ericsson acquired us, and they've collected a number of other TV companies along the way that do media stuff. But essentially, if you're watching live television, pretty much anywhere in Europe, it will have been through probably some part of our kit. We've got the physical boxes that go in the TV fans, so the DSNG, so that's uplinks from football matches, Premier League, etc. Sending that back to your production facilities where we're doing things like BBC, back office, Comcast, major American broadcasters, AT&T, Charter, where all of that's being collected into 3,000 channels and then sent out again. We distribute that out to local head ends, add adverts, all the usual kind of stuff, and then eventually that gets sent on its merry way via the various mechanisms that have been deployed over the sort of last 10 years. So it used to be just satellite, now it's IP, OTT, sort of terrestrial feeds and cable, at which point it ends up at your TV screen, your mobile phone and your tablet. Essentially, that's what we do. But the important thing to highlight, and it's come out in a number of the questions that have come from the audience, is we do everything in the sort of the pipeline. So we've got bespoke hardware, we've designed our own boxes, our own option cards, our own backplanes, high-speed links in a 2U server and a 1U server, all the way through to where we're heading now, which is moving away from bespoke hardware because our customers are expecting us to use Amazon Web Services, bespoke in-house private clouds, albeit with the increasing use of acceleration technologies, which means that Intel are putting FPGAs into the cloud. So suddenly now you do have bespoke hardware, we just don't develop it, it's just hosted by Amazon, but we have to still be able to use it. And that's the transition we're struggling with at the moment. To be honest, I could talk all day about CI. It's something that I personally am very passionate about. And in my role, it's sort of what keeps me sane in between all the other meetings that go with my role. The CI is where I like to experiment, try things out, feel the pain of my engineers, try and suggest some improvements and get in the room and actually have some conversations like this with those guys and say how can we make this better. But Jono asked me to limit the time I could talk. So I've picked up on 3 of our key challenges. The first is, and I think someone at the back there asked a question about what do we mean by CI. There are a million terms for what CI is, and the more religious, fanatical CI people would say it can't be branch-based development, that's not continuous. The sad reality for us, and probably for a number of you guys, is branch-based development is actually a commercial necessity. It isn't true CI, it doesn't meet people like Jez Humble, goes and does all this speech and says if you're doing on branches, you're not doing CI. Yeah, I accept that, but it's better than just not doing anything. But we live with branches, and that's because engineering agility, the ability to constantly push forward, isn't the same as customer agility. And I can assure you that our customers are not agile. You know, they want one change because if we mess it up, Super Bowl goes off, we're liable for huge amounts of damages. So we give them the least change possible. That leads us back to doing the least possible. It's on a dev branch. You can try, educate customers. Some of the software customers today that are very cloud focused are a bit more willing to have that conversation. Traditional broadcasters are risk averse, to say the least. Bespoke test environment generation. Engineers love to solve problems. My experience, maybe you guys, the engineers in the room, the fact you're in this room maybe counters my view of engineers in general. But many engineers love to build their own thing, but they're not so good at talking to each other. So you end up with loads of little environments dotted around your building where everyone spends some time gathering some kit, they get their hands dirty, they're quite excited about the fact they found some cables and an SDI player and a box and a video analyzer, and they put their code on it very proudly. They write the code, it works for me, and we go, that's good. And then they give it to the person next to them who's got a different test environment, and they say, it doesn't work for me. And we iterate around the loop as everyone runs around the building saying, it doesn't work for me. So for us, that's one of the key challenges we've tried to address. And for us, it just creates the two problems. Engineers are unable to replicate problems either between each other, and then you throw customers into the mix to go, we've seen this, and we can't even replicate it internally, let alone replicate the customer issue. And then when you do get more mature and you want to then start driving down the time between each of your releases, you go back nine years when I started, we had 6-month release schedules for our systems, and our systems were a combination of receivers, encoders. Our hardware's got faster, it's got more compact, we've put more stuff into one box, but we're now down to being able to change software and get a high level of confidence within a 2-week period of time. So we can turn something around for charter in 2 weeks. And that matters, that makes you more money, essentially, and that helps you persuade your management that this is a worthwhile expenditure in cash. If I do that. So I'll sort of gloss over this to a certain extent, but you've probably all developed something similar or seen something similar. In the middle of the picture, we've got our trunk, our main line, sort of depends on version control systems, what word you use, and our engineers create feature branches from each of those, as they want to develop something, and we try to keep the concept of an atomic unit of work, be it, can you add this bit of value to the customer? We don't want 6 branches that all partially add a little bit. We've had models in the past, which is the embedded software engineer adds a driver, the middleware driver person adds some stuff that says read the driver, put some data somewhere else, and then the GUI person comes along and says, I'll make the GUI show a drop-down box that lets it work. We've had 3 commits. At no point have we actually finished the feature. Your project managers are running around, why haven't you finished it? So we try to make feature branches end-to-end, vertical. Has a huge number of challenges, could talk all day about that too, but teams having the ability to deliver everything from top to bottom. But within those development branches, we enable what's in the bottom right corner, which is our CI build and test run. And what we mean by that is on that branch, you can modify the CI pipeline itself. I think Wouter at the back asked a question about CI to test CI. Steve just spoke about putting code with the jobs. So we put all of our Jenkins files, it goes with the branch. If you create a branch and you want to add more artifacts, change what you're deploying to, change the server, you can do that on a branch. You have an impact in mainline, but you're actually changing your CI infrastructure. We also do the build. Normally that's sort of basic engineering. Does it actually result in a complete compilation? But in parallel to that, we run our unit tests. We've started adding security scanning because our customers now care about security. So we've started having to build in security scanning tools. We're producing Docker containers, outputting virtual machines. We're deploying that to the cloud, physical hardware, updating firmware images. This is all going on, and we're trying to do that in a time period that doesn't mean the engineer says, I'm done, I'll come back 3 days' time. So you're trying to get as much feedback as you can. So that comes with a cost. How much equipment can you afford, and how much of that can you do in parallel? We repeat that exercise as many times as we've got as many engineers. The key thing here is you'll notice there's another magical diamond, which is when the merge comes back, we try to validate the merge coming back. So in our case, if you take one of our products, we typically essentially lock the trunk and say no one else can commit. The automation system then puts the code on, checks it works, ensures that the tests are still green, and then unlocks it so the next person can do it. And then we've built a queuing system built on Trello that allows you to queue those jobs up overnight, and it just sits there taking next branch, next branch, next branch. The version control systems try to handle the fact you're patching on patching on patching. Some days you've just been unlucky, 2 people have modified the same file. But that comes back to your feature branch sort of concept. If people are doing end-to-end features, you hope you're not overlapping so much. If I go to the next one. So to enable the sort of works for me, and one of the key changes that we've made over the last 9 years is we introduced a concept of islands, and this really took off with our C2 project maybe about 3 years ago. And the idea here is you create an isolated sort of group of equipment that you can essentially stamp out as many times as you want, and you say how much each one costs, and you go to your manager and say it's going to cost us this much to build this island. He says you can have one. You build one, and you say, if I had two, I could do things twice as fast. And you build a bit of momentum behind it in that way. But bespoke test environments, deploying things on top of each other, engineer A pulls the cable out back. I don't want that SDI feed, I want this SDI feed. Well, why doesn't my test work anymore? Well, you're not looking at the BBC anymore, you're using an ITV feed. Oh, right, thanks. I'll go round, break into the lab, fiddle with some cables that I don't know what I should be doing. Oh no, I've broken someone else's CI. So each island is isolated, so either virtually using VLANs and IP, or physically where we're using SDI players and playout machines. We clean the island before start. So we've got a streamer and an analyzer, and those are now deployed as Pixie boot machines. And then we use Docker containers to actually give them the functionality to do their job, which means you can just black the machine, re-Pixie boot it, and then say, Docker run this container, please. The physical hardware, restore to factory defaults. It's what our factory does. It's what goes to our customers. When all goes wrong at the customers, they pretty much hit the factory reset button. So we actually test that every time we do a test. And some of the things that's found, we found bugs in our flash driver that was just a generic problem in an MTD driver from the Linux kernel. After 10,000, 15,000 reboots, we were getting a problem where the units wouldn't boot. Our CI system found that, and then we had to feed that back to the Linux community. So, you know, sort of a side effect, but you can see that value would have been embarrassing with a customer when they go, why is our kit not booting? This ensures a repeatable start condition. And for the dev support group that sort of try and maintain this infrastructure, when they build a new island, we've developed some Jenkins tests that basically commission it, and it does some basic sanity checks. Can all the equipment see each other? Can you ping all the devices in the island? Can you put a TS through it? For those that aren't from a broadcast background, an input transport stream, sort of video. Put that in, check we get video out the other end, and it's what we expect to see. So that gives us confidence we haven't just built another bespoke environment. The test equipment, again, we said, it's trying to be as minimal as possible. So Pixie booting as much of it, essentially, so that we don't end up with layered on layered complexity. What is that test analyzer? What version are you running? It's running these Docker containers stored globally. It's running this version of software in our bespoke hardware. We deploy our test material, whether it's transport streams, in other cases different material, automatically. It caches locally, but essentially if someone says, I want to try a new test and a new transport stream, we've got a big hard drive somewhere with streams, and then we copy those locally. So the first time you run that test, it's a bit slower. Subsequent tests, it can cache it. And Jenkins labels are used to specify content to the island. Again, we've done quite a lot with Jenkins over the last 5 years to sort of make this possible. But we label our islands as having capabilities, and then Jenkins has the algorithm in it that we just inherited that says, you know, I need a machine that's got these labels. So what we can do is we can say this one's got a physical SDI feed, this island's got a C2 with this version of software, and another one says I've got an IP feed, or I've got 6 option cards plugged in. Because there are cost pressures, you can't put 6 option cards in every chassis, that's expensive. So you end up with tests being assigned by Jenkins to those islands just based on the labeling concept. So we're not trying to fight Jenkins here, we've just tried to use what it already knows about when doing compute jobs and handing them out. So a bit more detail here, we got SVN, Git, Snap, it's as usual. People started with SVN, we're trying to encourage use of Git. It polls. We use Docker containers to do our builds on the servers. So engineers, essentially, it has a standard Docker container with all the build tools in it, and that gives us a reproducibility for the build. And engineers can use the same Docker containers on their PCs to do their development. So if you start adding a new tool, it's common across the board. We clean the environment. And an island, we've got a GUI VM because we're driving tests as if you're a customer. So we've got Selenium testing, clicking buttons and seeing what happens when. Simulators, any number of them, but we say CA systems, so when customers are trying to protect their content, there's any number of content protection sort of vendors, but we've got simulators that generate those messages and put those into the system and say, here's a key, here's a key, here's a key, and if a key goes missing, the video goes blank. IP streamers, we've actually got any number of streamers, so we've got IP, which is quite easy, it's sort of virtual playout if you like, but we've got physical SDI players where they're putting a signal on a cable that is plugged into the unit, and things like 2110, 22-6, these are all sort of broadcast standards. And those are physically plugged into our UUT, so that's our unit under test. So that's a real piece of kit that's shipping, we've bought from our own factory, we've put our own hardware in, a collection of option cards. And increasingly, that's now Intel servers. And we've even taken this island concept and moved it into the virtual world where we've built virtual islands in Kubernetes. So we assign certain pods of resource within Kubernetes, and you can have N of those in your cloud. But you still have GUI pods, simulator pods, IP streamers. All of these are just virtual streamers, but they still are physical entities, and they're still based on our Docker containers, which meant we've been able to reuse a fair bit. And then in between, we've got our controller, and that's another sort of container. It just collects common Python tests, the sort of infrastructure you're running, test sequences, so the list of things you want to test. We've got Test Station, in-house developed XML script that essentially says, click this button, wait for this answer. And increasingly, we've started to move towards robot tests. So if you've heard of Robot Framework, it's another open source tool that you can borrow and use, and it's quite powerful. And that's sort of an island. The valuable results, historically, I think every software company or sort of hardware company has been through the same. We've got 3 departments. You've got sort of the hardware design department. They do their things. They hand it to the software department, who then hand it on to another part of the software department, who then go and give it to your test department. What we've tried to do is move the test islands back to the engineers. And then because the engineers have got control of the Jenkins file that determines what you're doing in CI, they're driving what they want to see. So if an engineer sits there one day and says, I would really love it if I captured the core dump, they've added some scripting to capture the core dump. So they've plugged a USB stick into the front of our hardware. We've modified our software that when we get a core dump, it writes to that USB stick. And at the end of our build, we can take that off the USB stick, attach the core dump, and put it into our Jenkins job. And then when it goes red and everyone goes, why did it go red? Oh, there's a core dump. Then go and put that through all your standard tools and go, that's interesting. And they can raise a defect, and then that can go around the loop. So the engineers drive what they want to see. Managers don't tell them what they want to see. That's pointless. So they've gone from logs from tests, logs from the unit under test, logs from the things that are actually running and providing the material. We capture Wireshark, the inputs, the outputs, the teeth, the transport streams, the analysis logs. We've got video capture because it's a VM that's running our GUI. You can just basically point a couple of open source tools at it, capture it, you get an MP4 file that says what you were clicking on. The amount of times people say, I clicked this button and it didn't work, when you replay it, you realise the button wasn't there, but you can only see that if you've got the video. We've captured serial debug, so in the islands, we've soldered cables onto every UART that's on all the option cards, fed them out the back, plug them into a PC, and when we start, we just say capture everything. Core dumps, unit configuration, so we take all the XML that we're using internally and we whack that into the job as well. And as I said, all that takes up space, but space is a lot cheaper than engineers, so just fill up space. We've had some conversations with other parts of the business where they say, we've run out of space, just buy another 500 gig hard drive, just repeatedly, go and get one a day. It's cheaper than your engineers going, I can't reproduce this problem.
In terms of analyzing all these data, all these logs, what do you use to analyze them?
So some of it's automatic, things like Wireshark captures and things, you can just sort of put IP, there's sort of IP tools that can tell you there's problems with the IP stream. Other times, you only need to look at it when it's gone wrong. But the amount of times that you have conversations where you say, well, we won't capture it unless it goes wrong. Well, now you've got to reproduce it going wrong in the first place. So we just try to capture everything all the time so that when we get a red test at the end, so for us, when video doesn't come out, which is the sort of primary purpose of our existence, the test goes red and everyone, why is that? Sometimes it's the unit doesn't boot, sometimes the power's failed, sometimes an option card has fried itself. There's any number of reasons. But you don't want to then say, I wonder if I can reproduce what happened. So we just capture everything all the time and then try to remove the excuse, if you like.
And when you do identify an error, what's sort of like the mean time to resolution? How long does it take?
That is an open-ended question. So it goes red and you can look at the problem. We have a triage, so every week the teams have got people that are having a quick look and going, it was that. The actual fixing of it, we end up with the usual problem of, is it a permanent problem? In which case you have to get someone on it and fix it. And at that point, it could be revert the branch. How did that happen? But hopefully you've protected against that because it hasn't ever gone to your main line. So the engineer just says, I've got more work to do. If you've got the standard problem of intermittency, which is 1 in n of your tests, just goes red. It's good enough that the engineers are sort of starting to trust the system, but the intermittency is high enough that people start to sort of, oh, it's okay, it's red. Now you've broken that trust level between the engineers, the managers and the automation system, which is it becomes okay to be red. And slowly over time, it's always red. And then people start just chucking any old crap in because it's red. What difference does it make? Oh, I can fix this. So you have to be really strict on it's green. And then for the intermittency, we have to put that back into the system in terms of prioritization. And then you've got to have a conversation with our TPMs and Scrum Masters and say, we need to prioritize this. And this is where there's the eternal conflict between project management and line management in my role. We're meant to look after quality. It will always be green. The project managers, we will give it to the customer. Little bit of a fight between the two because sometimes being green means you've got to be late to the customer. There's an eternal battle. It can be healthy, it can be unhealthy, but you have to at least be open about it. So we just put the defect back in the system and we see if it happens again. And if the rate of intermittency creeps up, at some point we start saying we've got to fix this. If it's manageable and we can always triage it accurately, we might live with it for a period of time.
Your last segment, I just let me take a question of the same sense, which is in terms of strategy, convincing the stakeholders, so the stakeholders, customer, business, architects, engineers, test people, convincing that, let me call them triage as well,
Yeah.
individuals on the benefits of using CI. How do you manage to do that? Because you said 9 years ago, 6 months,
Yep.
now you're using every 2 weeks, which is a very
So-
big change. So how do you convince the business? Was it bit by bit? Was it you just went ahead, did it, and then showed them the benefits, and then people?
There's the sort of standard engineering approach. So myself personally, when I started 9 years ago, I was just an engineer and just believed it was a good idea. So we started doing more, and the engineers around me, we were doing the same thing. Left Philips, where we'd done a lot of this stuff, and went to other companies. Why aren't you doing this? You know, it's no different. So there's a little bit of that, but eventually, money talks. And what you have to do is convince them that it's cheaper to buy islands, even if they cost £100,000, you know, to buy all the kit and you put them in a rack. Yeah, the cost of an engineer over a year is that, and you need some evidence to back it up. We've gone from a team of 100 people working on one of our projects to a team of 15 people managing that today and releasing in a 2-week period of time. Okay, we've reduced what they're being asked to do, but at the same time, we've got 10,000 tests that have told us it's been good to this point. When it goes red now, well, it must be something we've just changed. It hasn't just happened. And that's valuable, and that convinces your stakeholders. But you always need someone above you that you can convince. But in the end, it does make a difference and allows you to scale your operation. The key other point here is going back to the bespoke environments. These islands that we've built, and we generally hide in a data lab which has got security card access to try and minimise the fiddling that engineers love to do. We allow them access to those islands virtually, so they can run a single job on an island, so they don't have to wait for the whole CI suite. They can say, I'm modifying this, I want to run that one test against an island. Jenkins will schedule it and give them the results. So if they know they're doing something risky in one area, they can get a pretty quick answer on that one example test, and they can change things. They can do things like increase the debug level, which has huge problems with performance. If you're doing, if you turn all the debug levels up, we all know, oh, it suddenly starts working. You don't want that in your normal build, but you want to give them the ability to capture more. So we give them huge amounts of flexibility to do everything, because at the end, it just splats everything back to start, and the next person doesn't inherit that problem. And for us, that solves the works for me problem. And that's, as we say, sausages, and that's the end.